Okay, so we've been talking about multiplication, specifically basic facts in this chapter. Because in order to do greater facts, you have to be able to do the basic facts. So let's look at this example. So I'm going to read you a problem. I'm going to write a problem on the board. Maya has 4 scented markers. Okay, so Maya has 4 scented markers. Cole has 6 times as many. How many scented markers does Cole have? Okay, so the question in this problem is, how many scented markers does Cole have? Well, first we see the unit. The unit comes after how many. So we know our answer will be in this unit. Now, if we look at the problem, we have Maya has 4 scented markers. That's how many she has. And then we have Cole has 6 times as many. 6 times as many what? Victoria? Scented markers. So 6 times as many is our other important piece of information. The word times usually means we are multiplying, and it can sometimes mean that we're dividing. Usually it means we're multiplying. So if Cole has 6 times as many markers, does that mean he has more or less than Maya? Think about that. If you heard that somebody had 6 times as many as somebody else, would you think, oh, they have more, or oh, they have less? Aaron?
They have more.
More. So which operation gives us more? Multiplying or dividing?
Multiplication.
Multiplication. So what we're doing is we're taking Maya's 4 scented markers and we're repeating them 6 times to represent Cole's scented markers. So here's Maya's box. There's her crayon box or her marker box. Now if we repeat this 6 times, we'll get however many Cole has. So there's Maya's first one. 1, 2, 3, 4. A second one. 1, 2, 3, 4. A third one. 1, 2, 3, 4. A fourth one. 1, 2, 3, 4. A fifth one. 2, 3, 4. And a sixth one. Now Maya just has 1. So Maya has how many markers? Michaela? 4. But Cole has all of these. You take Maya's, he has 6 times as many, so you take Maya's, you multiply it by 6, and we get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So how many markers does Cole have? Smith?
24 scented markers.
24 scented markers. Now, if this was a word problem that we had, is this enough? 24 scented markers? What else do we need to show that we fully know what we're doing? What else do we need, Cullen?
Our equation.
Our equation. What is our equation? We know the answer is 24. We have the unit, scented markers. What does the equation look like?
4 times 6.
4 of Maya's markers times 6, because Cole has 6 times as many, equals Cole's 24 scented markers. Okay, so that's kind of what we're going to be doing today. We're going to see times as many quite a lot. So, let's go ahead and look at page 147. Go ahead and read the sentences under the title. That's me. Aaron.
Sometimes,
A little louder.
sometimes a problem uses a phrase like times as many, times more, and times as much. These kinds of problems are
What base word do you see in that word? What smaller word do you see inside of that word?
compared.
Compare. So if we say compare and then add ISON, how would we say that? It's a short I sound. Comparison. Good. That means it's a comparison is the noun version of compare. To compare is a verb, something you do. But a comparison is a thing. It's when you have compared something. That's a comparison. So read that sentence again.
Sometimes
You can just read the second one.
these kinds of problems are comparison problems.
Good. So sometimes you'll see phrases like times as many, times more, and times as much. Those are comparison problems because it's not like the problems we've had where there are 6 baskets and there are 3 apples in each basket. How many apples are there? Where you're multiplying the number of baskets times the number of apples in each basket to get how many apples? Victoria? 18. That is not a comparison problem because you have 6 baskets, 3 apples in each basket to get 18 in all. But in this one, we're comparing how many 2 people have. Maya has 4 markers, Cole has 6 times as many. So are we saying there are 6 boxes with 4 markers in each one? How many markers are there? No, we're saying Maya has 4, Cole has 6 times as much. There's no boxes or anything. We can still solve it by making a model, but there's not actually 2 objects. There's not actually an actual group, like a basket or a box or whatever. We're making it in our head. So, let's look at example 1 to see another example of this type of problem. Okay, so everybody, finger or pencil on example 1. When I see everybody's finger or pencil on example 1, I will continue. Sorry, can you lower the screen a little bit? Remember, I need to see you and what you're working on.
It's down.
I need it a little more because I can only see you. I can't see your book or anything. A little more. Okay, that's good. Well, it's going back up. It's right back to where it was. There you go. Okay, so read in your head while I read out loud. Mary attended camp for 7 days this summer. Tyler attended 3 times as many days as Mary. Find the number of days Tyler attended camp. So our question is not actually a question, it's a command. It's telling us to do something. It's telling us, find the number of days Tyler attended camp. What's our unit going to be? Look at that question. What is our unit going to be? Carla?
Our unit is going to be days.
Days. Because the question says, or the command says, find the number of days. So we need to say in our answer, blank days. That's how many days Tyler attended camp. Okay, now that we have found our question, or in this case our command, and our unit, let's reread the problem to find the important pieces of information. Mary attended camp for 7 days this summer. Well, there's a number with our unit, so we know that has to be a part of our problem. 7 days. Make sure that you are doing this with me, that you are boxing important information and underlining and circling and labeling like I am. That will help you when you're doing word problems. You can go back and look at the example problems and see, okay, well in this case, days was the unit because it came after find the number of. It's a pattern. Math is all a pattern. That's why we do these examples, because all of your independent practice and your homework will be similar to an example or a guided practice. You're just using different numbers. Math is a pattern. So we have the first piece of our problem, 7 days. Tyler attended 3 times as many days as Mary. Well, we see our unit again, but this time we don't see blank days. We see 3 times as many days. We see that word times, which tells us we're going to be doing multiplication or possibly division. So we have 7 days and 3 times as many days. Well, we know 7 is part of our problem, and we know 3 is going to be part of our problem. Now we need to know times as many days. If somebody attends 3 times as many days as somebody else, are you going to think, oh, they attended more days, or oh, they attended less days? Colin?
More.
More. Which operation gives us more? Multiplication or division?
Multiplication.
Multiplication. So that means we're going to take Mary's 7 days. We know Tyler attended 3 times as many, so we're going to repeat Mary's 7 days 3 times, and then we'll get how many days Tyler attended. So, step 1, we're going to make a model. We're going to model Mary's days at camp as a group of 7 days. How many groups of 7 days did Mary attend camp? Smith.
1 group.
1 group, because she only attended 7 days. 1 group of 7 is how many, Smith?
7.
7. If you have 1 group of 7 beads, well, you only have 7 beads. Since she only went 7 days, we're going to model her days as 1 group of 7 days. So let's draw our model. I'm going to draw counters, which are just little circles. Because sometimes when you guys do the grids, you just kind of make lines and don't really pay attention to how many you're doing. So let's draw counters, which are just circles. We're going to model Mary's group of 7 days. 1, 2, 3, 4, 5, 6, 7. There's her 7 days at camp. Make sure you're being neat. Make sure that you're kind of lining them up as best you can so that when you're counting, if you have to, you're not accidentally counting one circle more than once. Okay, so there, we've done step 1. We've modeled Mary's days at camp as 1 group of 7 days. Now step 2, Tyler attended 3 times as many days at camp. So we're going to model Tyler's days at camp as how many groups of 7? Carla? You're still muted.
3.
3. So here's Mary's days. Now let's model Tyler's. We're going to model Tyler's days at camp as 3 groups of 7. So let's draw 1, 2, 3, 4, 5, 6, 7. There's 1 group. 1, 2, 3, 4, 5, 6, 7. There's our second group. 1, 2, 3, 4, 5, 6, 7. And there's our third group. So we've got Mary's 1 group. Let's draw squiggly lines so we know that they are not connected. They're not the same. We're not going to count these as part of this because here's Mary's, here's Tyler's. We've got Mary's 1 group of 7 days. We've got Tyler's 3 groups of 7 days because he went 3 times as many days. Mary went 7 days. So Tyler went 3 times as much as that. So now we're going to find the total of the 3 groups of 7. Am I going to count Mary's days in this? Zadie?
No.
No. So the first group, how many are in the first group? How many days are in the first group? Victoria? 7. How many are in the second group? Michaela? 7. How many are in the third group? Zadie?
7.
7. Do I have any other groups? Class, do I have any other groups?
No.
No, because I don't want to count Mary's groups. Tyler didn't go those days. Those are Mary's days. So now we have to do 7 plus 7 plus 7. Well, is it easy to add three numbers at once in our head? Zadie?
No.
No. So what should we do? We should use the associative property to make groups, right? So we should do, what group do you want to do first? 7 plus 7 or 7 plus 7?
7 plus 7.
7 plus 7. 7 plus 7 is what?
12.
Not 12. Colin, can you help her out?
14.
Oops. 14. We're going to write it small. And then we bring down the rest of our equations. 14 plus 7 is what?
21.
21. We don't have to do another caret because we can just put that in our answer. 21. What does 7 plus 7 plus 7 look like as a multiplication problem? Zari.
Seven times 3.
7 times 3. Because what are we doing with 7? We're repeating it how many times, Zari?
3 times.
3 times. And Zari, 7 times 3 equals
21.
21. So Tyler attended camp for how many days, class?
21.
21 days.
21 days. Thank you, Zari, for saying the unit. Now let's count. Let's check by counting the counters in our model, just to be sure. Count with me. Make sure that you do not count. This is something I had to work on with the preschoolers when I taught them all the time. Do not count until my marker touches that counter. So if my marker has not touched the counter yet, don't keep counting. Otherwise, if we get off track, we're going to count way too many or not enough. So do not count until my marker touches the counter. 1, 2, 3, 4, 5, 6, 7, 8, 9.
10.
Carla, are you making sure that you're not counting until I touch? 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So we were correct. Good. It didn't take you guys as long as it took the preschoolers.
Did they keep saying?
Good.
Did
They would keep going. Because that's actually a really important thing to learn. Like not counting until you're touching it. Okay, good. So we got it right. So do you see how it's different than the type of problems we've been looking at, where there's a group, like a basket or a box or something, and there's objects in it, and we're repeating that to get the answer. This is different because we don't have multiple objects. We don't have a group, a physical thing that can hold multiple items, and then we're figuring out how many items there are in all. This is different. Okay, let's go ahead and look at example 2. Let's look at the next page. So helper number 1, please sanitize, erase, sanitize. Okay, so before we get to example 2, we have another sentence. That means we're going to be looking at something a little differently when we get to example 2. If we have more sentences on the next page, that means we're going to be doing the same concept, but we're going to be looking at it a little differently. So please read those sentences at the top of the page, Kingston. Loud and slow.
The type of model line is a bar diagram. A bar diagram can help understand a problem and plan to solve it.
Good. So what we're going to be looking is at, in this example, are bar diagrams. So make sure that you are paying close attention because bar diagrams have to be set up in a certain way. Put one of those on my desk. Just kidding. Never mind. I didn't realize what that was. Okay. Bar diagrams must be set up a certain way. Part of your points when you're doing your homework and your independent practice and your test is that you are setting it up the correct way. As long as you are focusing and paying attention and going back to your examples and the ones that are already completed, you will know exactly what to put where. So everybody, finger or pencil on example 2. When I see everybody's finger or pencil on example 2, I will continue. Okay, read in your head while I read out loud. Suki used 15 beads to make a bracelet. This is 3 times as many beads as what Cassidy used. How many beads did Cassidy use? So we see our question, how many beads did Cassidy use? What's our unit? Carla?
Our unit is beads.
Beads, because it comes right after how many? So the unit our answer will be in is beads. So our answer will be this many beads. Okay, let's reread the problem to find our important pieces of information. So we have Suki used 15 beads to make a bracelet. Well, we see a number in our unit, so we know that's our first piece of information, 15 beads. Now, this is 3 times as many beads as what Cassidy used. So we see 3 times as many beads. Bead times tells us we're going to be doing either multiplication or division. But usually we've been doing multiplication. But there's a word here that tells us we're not going to be doing multiplication. It's the word this. This, who can tell me? Who thinks they know? What part of the problem does the word this refer to? What part of this whole word problem does this refer to? Carla, you want to try it out?
Yes, ma'am.
What do you think this refers to?
I think this refers to division because there's
Nope. There's a part of this problem that this refers to, an actual words in this problem. This refers to the number that comes before. So the word this means that those 15 beads. If you see this is blank times as many, then you know whatever number came before this in the problem is what this means. So we can read this as Suki used 15 beads to make a bracelet. 15 beads is 3 times as many beads as what Cassidy used. So we have 2 pieces, 15 and 3. But if 15 is 3 times as many as what Cassidy used, did Cassidy use more or less than 15 beads? If 15 beads is 3 times as many, it was what Cassidy used. Did Cassidy use more or less than 15? Victoria? Less. Good. Because this would be like saying Tyler went to camp 21 days. This, 21 days, is 3 times as many as Mary went. Because we're saying this number is 3 times as many or 3 times more. So, Victoria, which operation gives us an answer that is less than any of the numbers in our problem? Division. So now we know we're doing division. We have 15 beads and 3 times as many beads. How do we have to set that up in an equation? Which one has to come first? 15 or 3? Zadie?
15.
Why?
Because the bigger number comes first in division.
Good, because the bigger number comes first in division. So we're taking the 15 beads and we're dividing it by 3 to get whatever our answer is. So make sure that you are paying close attention, because if you tried to say 15 times 3, well, first of all, that's not a basic fact, and we're not working with anything but basic facts right now. But you would get a completely wrong answer. You would get a massive number that Cassidy used when the problem is saying this, the 15 beads, is 3 times as many. 3 times more. Because if you see 3 times as many, 3 times more means the same thing. So if you know 15 is 3 times more than another number, is 15 bigger or smaller than that other number? Colin?
15 is...
If 15 is 3 times more than another number, is that other number bigger or smaller than 15?
The other number is smaller.
The other number is smaller. So pay close attention, because if you are just going through quickly to try to get finished, you're going to miss the word this, or you're just not going to pay attention to what this means, and you're going to multiply, and you're not going to be correct. So, look at this bar diagram. It models this problem. We have this box. Wait, hold on. Use your pencil. Remember, if I'm going over lines, you're going over lines. So Cassidy's beads are represented by this box with an unknown and beads. So Cassidy's beads are represented by this box. So when we create our bar diagram, we know that Suki has 3 times as many, so we need to repeat Cassidy's beads 3 times. We know Suki has 3 times as many, which also means 3 times more than Cassidy. So we repeat Cassidy's beads 3 times because Suki used 3 times as many. We know Suki used 15 beads. So this is exactly what our bar diagram looks like. At the top, we have the total number of beads. In the bottom, we have the piece repeated however many times. We know Cassidy used this many beads. We don't know how many it is yet, but we know it was repeated 3 times to have the same number as Suki. So step 2, find how many beads Cassidy used. 3, 1, 2, 3, times something, whatever this number is, equals 15. The same as 15 divided by 3. Well, 3 times what equals 15? Zari.
5.
5. So that means each of these represents 5 beads. If I repeat 5 3 times, do I get 15? Well, let's check. 5, 10, 15. Is that the same number that Suki used? So are we correct? So when you set up, so Cassidy used how many beads, class?
5 beads.
5 beads.
5 beads. So when you set up a bar diagram, you just set up something that looks like this. Kind of like a football goal, but with an extra piece. Or you can say this is the ground. You know, like how a football goal is 2 poles with a line across the middle? Well, here's the ground. And then now we have just this little dotted line that we're adding. Like, say, you know how there's a net behind the football goal? We can imagine that as the top of the net. And a net has holes in it, so that's why our dash has holes in it. Up here, so go ahead and model this. Draw this to the side. Up at the top is the total. Whatever the total is, the largest number, the 15 beads, like in this case. I'll give you a second to do that. And what we're going to put in this bottom part is repeat the smaller number the times as many or times more amount. Instead of repeat the smaller number, take off smaller number, repeat the number of objects. In this case, it was beads. So repeat in the bottom, you repeat the number of objects, the times as many, or the times more amount. So whatever the problem says, blank times as many, blank times more. That's how many times you repeat the number of objects. Once you're finished with that, now that we know that, we'll look at this one to see. Okay, so when you're done copying that model, that blank model, the model template, a template is something that you go back to and you just replace what it's telling you with what you need in that moment. Put your pencil down so that we can look at where these things are in this bar diagram. And then we'll do one of the independent practice bar diagrams together. We'll do the guided practice, and then we'll do either numbers 8, 9, or 10, depending on which one looks the best on the camera. Okay, so on this template bar diagram at the top, in those dashed lines, we have the total. We have the largest number. Well, in this problem, that was 15. So we have 15 beads at the top. Then we know in the bottom part, this part between the bottom of the field goal and the ground, if it was a football goal, you repeat the number of objects. In this case, it was 5 beads. The times as many or times more amount. Well, in this case, our object was 5 beads. The problem told us to repeat it 3 times because it says 3 times as many. So we repeated it 1, 2, 3 times. Does everybody see that? Let's go ahead and look at the independent practice bar diagrams while we've still got this fresh on our minds. And then we'll go and do the guided practice. So look at numbers 8, 9, and 10. Whenever I pull it up, we'll see which one looks better, and that's the one we're going to do together. Actually, no, let's do number 2. Number 9. Sorry. Okay, so number 9 says, everybody look at number 9. The directions for this part say complete each bar diagram, then complete the multiplication equation. So number 9 says 2 times as many as 3 bows. Well, we know 2 times as many, so how many boxes are going to be in the bottom of our football goal? If we know 2 times as many, how many boxes are we going to have? Remember, we know on our template, the number of boxes is however many times as many or times more the problem tells us. Zadie? 2, because we have 2 times as many. So that means we have 2 boxes at the bottom. Make sure that you're labeling all these things. 2 times as many means we have 2 boxes in the bottom of our football goal. Now, inside the boxes, the number of what goes? What goes inside the boxes? The number of what? Look at your template, your blank template. Aaron? The number of objects, which in this case, what are our objects? Bows. So what goes inside each of these boxes? Well, what goes inside? So what number goes inside each of these? We're putting the number of objects. Our objects in this case are bows. How many bows do we have?
3.
So what goes in each of these boxes? 3. So we have 3 bows and 3 bows. Now what goes here? Look at your template. What goes here? In the top, in the dashed lines. Look at your template because it tells you the exact thing that goes there. Zari.
The total.
The total. So at the bottom, we have our number of objects repeated however many times as many the problem told us. So if we have 3 and we're repeating it 2 times or twice, how many bows do we have in all?
6.
6. So does everybody see that? In the top, in the dashed line, is the total. In the bottom, well, we have however many boxes the problem tells us times as many or times more. In this case, it said 2 times as many, so we have 2 boxes. Inside the boxes goes the number of objects. Well, we know 3 is the number of objects, so we're putting 3 in each box. Our total is however many this is in all. If you repeat 3 2 times, you get 6. So what does that equation look like? What does that multiplication equation look like? Carla.
3 times 2.
Equals?
Equals 6.
Good. Because we have 3 bows. 3 bows. We're repeating it 2 times to get a total of 6 bows. So does everybody understand bar diagrams? As long as you look back at that template and look at what you know and look for words like times as many or twice. What does twice mean? What does twice as many mean? Victoria? What does twice as many mean? It might mean multiplication. What does twice as many mean? 2 times. Twice means 2 times. On your homework, on your spelling homework on Monday nights, it's write twice. Well, twice means the same thing as write 2 times. So if you see twice, you know that means 2 times as many. So don't just look at twice and say, I don't know what that means, because you know it means 2 times as many. Okay, everybody understand bar diagrams? As long as you're looking at your examples and you're looking at that blank template I gave you, you will be just fine. Okay, let's look at the guided practice really quick. So helper number 1. Okay, so the guided practice says, use multiplication or division to complete the equation for the phrase below. Well, we have 3 times as much, and we have a model of 3 objects. So if we're saying 3 times as much as 3, we're saying 3 times 3 equals blank. Well, 3 times 3 equals what? What does 3 times 3 equal? Kingston? 9. So if you see a problem like this, 3 times as much, 3 times as many, 3 times more, and then a model, you're saying blank times blank. However many times as much times whatever the model is showing. Okay, so you have like 2 minutes until it's time to get ready for reading. 3 minutes, but that's the perfect amount of time to answer the critical thinking question on page 150. So go ahead, answer. Oh, wait, hold on. I'm sorry. Let's look at the independent practice actually and see what you're going to do. So numbers 3 through 4 are just like this guided practice. Numbers 5 through 7, you have to figure it out. It gives you part of the problem. So it gives you the answer. So it gives you the first part, the blank times as much, and then it gives you the answer. So you have to figure out how many objects, how many counters are going to go in those boxes. You have to figure out what the second number is, and you have to model. Don't forget to put your counters inside the box. There's 2 parts. You have to put what number goes on that line in the equation. 10 times blank equals 40. What number goes in the blank, and how many counters are going to go in that box. Numbers 8 through 10 are just like number 9, which we did together. Numbers 11 and 12 are just like number 9. You just have to make the whole bar diagram. So you have to figure out how many boxes are you going to make. Use your template and it will help you. Use your template, which is that blank one, where I said what goes in each spot. and then use the examples to help you. Number 13 and 14 on the back. So look at the back. Numbers 13 and 14 tell you the directions say draw a bar diagram and write an equation to solve. I think, let me see.
Yes.
Does it say that for yours too? Yes.
Yes.
So that means in that blank spot, because I have the old version of the book, in that blank spot underneath each one, you need to draw a bar diagram. Do not draw a bar diagram. Are you paying attention? For number 13 and 14, you must draw a bar diagram. Once you have drawn your bar diagram, use your template, use your examples. You need to write an equation and then the answer. Number 15 is one of those ones where there's one of those do not belong. That means you need to solve each one. Once you solve each one, you'll be able to figure out what doesn't belong. Number 16 is the critical thinking. So go ahead and let's look at the homework. Numbers 1 through 6 are just like the guided practice, number 1. Numbers 7 and 8 are bar diagrams. So they're just like numbers 8 through 10 on the independent practice. Numbers 9 and 10, I have to look at yours because those are usually where they change. You need to figure out the equation and the answer. Number 11, you have a bar diagram to draw. And then number 12, you need to solve. Make sure you show all equations, make sure you show all answers, make sure you show all units. If it tells you to draw a bar diagram, what do you need to do? Zadie?
Draw a bar diagram.
Draw a bar diagram. Make sure you draw it correctly because part of your points is did you draw the bar diagram correctly? Use that template I gave you, use the examples, and you'll be just fine. Okay,